Okay, guys. I don't have your quizzes back for you. Hopefully, I'll have them tomorrow, but I'm not making any promises. Um, but we're gonna go ahead and go on to 5.3 today, which is just some different identities. Honestly, it's definitely like new formulas to memorize, but they're not that bad. And honestly, they're easier because they're easier to recognize. So I don't think these notes will be too bad, and I also don't think the homework will be too bad as well. So you should all have a copy of these notes, and if you don't, just pause the video until everybody has a copy, and then unpause the video. But remember, like the first two sections of this chapter, we've just been talking about the fundamental identities and proving trig identities. Today we're just going to add in some sum and difference identities and simplify some other expressions, kind of show how we can get some exact answers as we do this. So um, we know how to get the exact value of like sine of 60 or cosine of 120. But if I asked you to find the sine of 75 degrees, up until now we've only been able to give a decimal answer for that. But think about, could you write 75 degrees as a sum or difference of two angles that we know already? And maybe you're thinking, if I can get my pen to work, that the sine of 75 would be the same as like the sine of 30 degrees plus 45 degrees. And hey, I know the sine of 30 degrees and the sine of 45 degrees, so how does that work? And so you can kind of see on the screen already here that there's some identities here. And so they look a little scary at first, like, oh my gosh, this is hard, but it's really not that hard. So just bear with me. So if I asked you to find the sine of two angles, and people always complain, why did I use u's and v's? I don't really know, but you could use a and b if you want, if you feel like you're writing, you're not going to be able to distinguish between u's and v's. But if you have the sine of two angles added together, you're going to take the sine of the first times the cosine of the second. So sine of u times cosine of v plus cosine of the first times sine of the second. So plus cosine of u times sine of v. And that's honestly how I think of it. Sine of the first times cosine of the second plus cosine of the first times sine of the second. And if you do subtraction, the only thing that changes, right? So you don't really have to memorize this as two separate formulas. But if you do subtraction, it's the same thing except for you subtract. So far, so good, right? Then we also have formulas for cosine. And for cosine, it's going to be cosine times cosine and sine times sine. But for cosine, it's the opposite sign of what's there, right? So for cosine of u plus v, it's going to be cosine of u times cosine of v minus sine of u times sine of v. And again, really important to notice here that there's a plus sign here and there's a minus sign here. And that's because in the sum of difference identities for cosine, like the signs change, which means that when we do subtraction, oh, I don't want that to be that. When we do subtraction, then we have addition there. So usually make sure you write those down. So subtraction goes to addition. Cosine times cosine, sine times sine. And we're just going to practice these, and I promise if you do the notes today and you do the homework, you should pretty much have these memorized. Tangent's easy to recognize because it has tangent in it, so tangent is going to be, tangent of u plus v is tangent of u plus tangent of v over 1 minus tangent of u, tangent of v. And again, notice on the top, I don't know, I have a subtraction one here of this. Oh, look, I do. Too bad I didn't cover that up, I guess. On the top, it's the same sign. Oh my good gravy. It's the same sign here, right? But it's the opposite sign in the bottom. So whatever the addition, if it's addition there, it's addition on the top. And on this one, if it's subtraction in there, it's subtraction on top, and it's the opposite on the bottom. And again, if you just kind of practice these a lot, you're going to be able to memorize them. Okay, so let's practice. What does that mean to simplify these? Basically, you have to know the formulas, and you have to be able to think of two angles that you know. So, for cosine of 75, as long as you pick two angles that from the unit circle that add or subtract to 75, you're going to get the same answer as me. So you don't have to pick the same one as me. You don't have to pick the same order as me. We're going to get the same answer. But for me, I'm going to rewrite 75 degrees as 30 degrees plus 45 degrees, right? I usually try to stick with the first quadrant if I can. So that's step one. Step two is going to be simplifying that with the formula. So now that you have to look back at your formulas, which is on the previous page, cosine is cosine cosine, so that's going to be cosine of 30 times cosine of 45 degrees. And then with cosine, it's the opposite sign. So since we did plus, I'm going to put minus sine of 30 degrees, sine of 45 degrees. And now you just got to make sure you put the right numbers in there, right? So at 30 degrees, that's square root of 3 over 2, 1/2. So the cosine of 30 degrees is square root of 3 over 2. The cosine of 45 degrees is easy, right? It's square root of 2 over 2 minus the sine of 30 degrees is 1/2. And the cosine is square root of 2 over 2. And I don't want you to leave your answer like this because we can simplify a little bit. Remember that we can multiply square roots times square roots. So when I take the square root of 3 times the square root of 2, I get the square root of 6 over 4. 2 times 2 is 4. And over here, I would just get minus square root of 2 over 4. Now, we can't add and subtract, just like we can't add and subtract x minus y. So you can't put the square root of 6 minus the square root of 2 and equal the square root of 4, right? But if you wanted to, you could write that all over one denominator if you want, but I don't care really. But that would be the exact answer that you could give me there. And you can check on your calculator, do the decimal of that, and then take the decimal answer of cosine of 75 degrees, and it should be the same answer. So I did one with radians too, just to kind of maybe make you think for a minute. But let's say you're really bad with radians and fractions. Don't forget that you can always change radians to degrees. So you could multiply here by 180 over pi. And I think that's 15 degrees, right? So if you wanted to change it to degrees, like that's totally fine. But think about all of our angles, right? Pi thirds, pi fourths, pi sixths. Your common denominator is going to be twelfths there. And so it's not that hard to think about how you could write this in radians. So think about if I took pi fourths minus pi sixths. I don't know if that's going to work. Common denominator there would be 12. So I'd get 3 pi fourths, 3 pi twelfths, right? That would be 3 pi twelfths minus 2 pi twelfths, which would give me pi twelfths. I think it would also work if you did pi thirds minus pi fourths. You'd also get pi twelfths. And so don't overthink that, but again, don't stress a lot about it either. If you prefer to do degrees, just do degrees. But I'm going to do the radians just to have an example here with radians and have an example with sine. So remember with sine, the formula is sine, cosine, cosine, sine. So I'm going to just write that out over here. I'm going to say the sine of the first, which is pi fourths. And with sine, it's the same sign that's in the middle. So since, oh wait, like I already messed up. I got ahead of myself. So then it's the cosine times of the second, which is pi sixths, then minus, and then switch to the cosine and the sine. So now it's going to be cosine of pi fourths and sine of pi sixths. And yes, I want you to memorize these. They're not so bad. We have another lesson where we have some more formulas in, and I'm not going to make you memorize those, but I am going to make you memorize these. So I'm just going to plug these values in. So sine of pi fourths is square root of 2 over 2. Cosine of pi 6, I still have pi 6 up here, so that's square root of 3 over 2. Cosine of pi fourths is square root of 2 over 2. And sine of pi 6 is 1/2. maybe you realize that this looks very similar to where we were on number 1, right? Look at this line and look at this line. I think we're going to get the exact same answer here. We're going to get the square root of 6 over 4 minus the square root of 2 over 4. But that's not just a coincidence. If you think about our angles here, right? This was 15 degrees. This was 75 degrees. And what do you notice about 75 degrees and 15 degrees? They're complementary, right? So 75 degrees plus 15 degrees is 90. And remember that sine and cosine are cofunctions. And so that's why those turned out to be exactly the same. You're going to get lots of square root of 6s and square root of 2s. So don't freak out about that because those same values show up a lot in these problems. Okay, so the first couple problems on your homework are like this, where you're just using the formulas. And then there's going to be some where you're going to break stuff apart and put stuff together and maybe even verify some identities. So let's check a few of those. Like, I like 3 and 4 more than I like 1 and 2 because 1, it kind of helps you memorize the formula, and 2, it's just not so much time consuming as 1 and 2. But it says write as the sine, cosine, or tangent of one function, which means they want you to recognize the formula and they want you to recognize the angles there. So looking at number 3, you should be able to tell me, is that going to be a sine, a cosine, or a tangent? And since it's cosine, cosine, sine, sine, that's cosine, right? You can look back at your formulas. And then it's just the two angles, right? It's just pi sevenths and pi fifths. And then your other job is what sign goes in the middle there. Well, remember with cosine, it's the opposite sign. So since that's a subtraction sign, I'm going to put a plus sign here. And then your only job there is to add those together. And I'm just going to show my work here of if I get a common denominator, this would become 5 pi sevenths. This would become 7 pi sevenths. So my answer here would be, I don't even know what I was just saying, but 5 pi 35ths and 7 pi 35ths would give me 12 pi 35ths. So kind of going the opposite way. It's broken up in the formula, and then you put it back together. So look at the next one. Definitely that's tangent, right? So that's easy. The two angles are just the two angles right here. So that's just 2x and x. And then the question is it a plus sign or is it a minus sign? Well, it's always that top sign. So it's a plus sign. So we can just say tangent of 3x. Okay, so that's not so bad. There's some other examples in your book if you want to look at those. I just got a couple more here. This one's kind of like number 4, only with some actual number values. It says find the exact value. So it doesn't say like to put back together, but it's going to be hard to find the exact value because we don't know what the tangent of 25 degrees is or the tangent of 110 degrees. So this is where the formula, you just kind of put it back together, right? So it would be tangent of 25 degrees and 110 degrees. But then are you adding or are you subtracting? Well, that top sign is a plus sign. So we're adding. So that's the same as saying tangent of 135 degrees. And I do know 135 degrees. That's over here, right? So the tangent value, right? Tangent is y over x. And that's the same thing except for one's negative. So the answer there is just -1. So the only other thing that I have here that I want you to do is looking at some identities. And I don't know how the quizzes went because I wasn't here when you took them, but I know that sometimes what's hard about those quizzes or these problems is it's hard to know what to do. But when we get to sum and difference identities, I think these are easier to do because if I see a sum or a difference, I don't have to guess what to do on that problem. I know I can break it up using the formula. And so I no longer have to guess, should I get a common denominator? Do I need to multiply by something? I'm just going to use that identity. So I'm going to use the cosine identity that says I'm going to take the cosine of the first times the cosine of the second. Then I'm going to do the opposite sign. I'm going to say plus the sine of the first times the sine of the second. And then I'm going to try to simplify to see if that works out. And it is a proof, so maybe I'm going to show a little bit of work here just so that I can show where the answer came from. Cosine of pi halves, cosine is x, so at pi halves that's just 0. And the sine of pi halves is 1. So you can see there's really not much left of this proof here, right? That's just 0, and sine x times 1 is just sine x. And that's one of those cofunction identities, and then we just did the proof for it showing why that's true. Right? So that's not so bad. So take a second and try get started on the next one. It should be just like the one I just did, only there's a negative sign over there now. And then I'll be done. Do you agree that this almost looks exactly like the last one except for it's a negative sign because it's a plus in the middle? Right? They're not all this simple, obviously, but for the most part, they should feel better today on the homework when you get to these. It's just your job to know these formulas. Okay, so you should have some time left to work on your homework. So this is 5-3. Some of the ones at the end are the proofs, and I will be back tomorrow. And we'll go over questions for this, and if I have the quizzes graded, again, no promises, but we'll go over those either tomorrow or Monday when I have them graded. So get working on this so you guys can talk to each other, and we'll go over it tomorrow.